Hi, welcome to my Biostatistics lecture series. And what I intend to do in my lectures is I will give a very basic knowledge to understand complex concepts in biostatistics. And I don't really intend to lecture for students who are in the Department of Biostatistics or Statistics, but students who are pursuing other subjects than biostatistics itself as a core subject. Um, but people may just be benefited from this fundamental lecture. So this is my first lecture, and I would like to begin with some overview of relevant concepts to biostatistics. My name is Muhammad Mizanur Rashid Shuvra. I go by Shuvra. My background is medical science, followed by a master's in public health and a master's in early childhood development. So let's begin with looking at what this lecture series that will eventually turn into a course objective looks like. Okay, so really the unwritten course objective is, by the end of this course, you should be able to say that biostatistics is fun, and you should be also able to say that I can speak in statistical language. So if you can achieve those two, if you can make really biostatistics fun for yourself, obviously the achievement is yours, and it serves the purpose of my effort here. But having said that, of course this session itself will have a set of objectives. For example, by the end of this session you should be able to answer questions such as what is the process of inquiry leading to research, and there is a little bit of philosophy behind this discussion, but I will keep it to a very minimum. But as you can imagine, you are going to do research, and of course, based on that, you'll get data, and data is what biostatistics analyzes, right? So if we don't know the process, the proper process of inquiring, or at least have an overview of that, then biostatistics, you don't see really the relationship. So we'll go through that. The next question is that you'll be able to answer is how many research questions be answered? So, there are multiple ways, of course, of answering the same kind of questions in different ways, or different kind of answers to the same research question. But it all depends on whether you're able to reach the objective of your research question properly. The next thing is about the types of research inquiries. So basically, global standards have come to a consensus that we have two different kinds of research inquiry. One is a quantitative research, and the other is a qualitative research method, and we'll see how they significantly differ from each other. When can the research answers be accepted? Well, you may ask questions that are researchable, and you may have different ways of answering that, but how are those accepted, and how does biostatistics fit in there to answer the research question? To make it acceptable is another question. Then we'll see, of course, leading from there, the role and the processes of statistics to answer these questions. But this is a very brief and general discussion that I'll go through. The entire biostatistics lecture series actually tries to answer this question. The next, of course, is what is biostatistics and how is it used in various disciplines. You'll see that the basic concept of statistics or biostatistics or any kind of statistics are actually the same. Eventually, through all the lectures, you'll find the basics of all these things, and really, biostatistics differs very little from other kind of statistics in terms of the concept that it discusses. So we'll touch on that a little bit. So let's begin with the process of inquiry to research. If I ask you, for example, a question, such as, is there any difference in the drugs produced locally compared to drugs produced internationally? Well, let me tell you a little bit of the background of this question, because this is a really valid question for developing countries where quality control in drug production is really a concern. And oftentimes there are low quality drugs, but if you want to really compare that, you may ask a question such as, is there a difference? And I didn't really, if you notice that the question is not really very well phrased question, and we'll discuss about it a little later. But you could answer based on your ideas, experiences, information in many different ways. So which one should I take, and should I believe you or should I not believe you? And this all depends on a lot of things. So that's what we're going to look at, and eventually that's where biostatistics role come in to really say that, look, this is a process, a method, a scientific process by which you bring in evidence of in support of your research question, and then you analyze them again through mathematical statistical procedures, eventually to answer it with more confidence. And we'll see how that fits in and ties up with everything else. Continuing on the process of inquiry research, in ordinary daily life, we actually ask questions, right? We ask questions in many different ways. And what we do, we actually seek the answers. So basically, even if not we're doing things very formally, we're actually asking questions, just like research questions, and we're trying to find answers, but maybe we're not following their standardized, acceptable research methods procedure. But then we get answers, and we need to ask ourselves, are we really trusting the answers that we're getting, and what are these trusts depend on? So beginning from even daily ordinary questions, for example, a patient may ask a question about her or his illness to throw the question to a physician, and the physician is going to explain it and give the patient an answer, and the patient usually trusts that even without doing any kind of research, of course, right? Because he's an authority. So authorities are one way or one sources of trusting the answers, and there are uh, several different kind of authorities in different kind of disciplines, of course. And this pertains to really the discipline of social influence under social psychology, that people tend to believe authorities more often. So, just like students believe answers most of the time, the answers given by teachers, right? All right, so the next is how are people related to each other also kind of determines whether you're going to really believe the answer or not. So if you ask a question to a completely unknown person as opposed to someone who you have seen is very knowledgeable, and you know that you have a good relationship, the person is not going to cheat on you, you may really trust that person. One example that relates to authority as well as the relationship with the person is, kids tend to ask a lot of questions to their parents, and they actually believe them when the parents answer those questions, just because of the relationship that the child has with the parents. But also, usually a child sees a person as an authoritative figure, their parents as an authoritative figure. The next is, even if you ask the question to an unknown person, and the person really gives a logical statement, that logical statement can make the answer trustworthy. That's not very difficult to understand. And if with that logical statements made by that person, if the person can really bring some evidence with it and respond with the evidence that are really flawless, and it's of course a little bit of exaggeration to say that you have flawless evidence, but that's what even research tries to achieve. They gather evidence and try to make it flawless, and there are plenty of issues to ensure how research evidence becomes flawless. But if someone answers your research question with flawless evidence, you tend to believe the person even more. The answer becomes trustworthy. The scientific process of analyzing this evidence is the final, well, not the final, but then, one of the final stages leading to the trustworthiness of your research question. So the flawless evidence that you bring in, you aren't trying to respond with that, but it goes through a scientific process of analyzing this evidence, and that's really what biostatistics is doing. So the response with flawless evidence up to that would be your research data collected, but you need a way to analyze that and make a conclusion that's acceptable and standardized by different research communities, right? But finally, even if you have all this trustworthiness through all the things that discussed above, you may still ask, is this really correct? You may not always have an absolute answer to so many different questions, so you may ask for an alternative answers or explanation. So even if you get the answers that almost satisfies you, you could ask, could there be something else? Right? So we all know that smoking causes lung cancer, and it has been proven with many different kind of research. But you may ask, has genetics any role in there? Has different kinds of smoking, tobacco content has a role in there? So you never know what's other things are playing a role in there. Is the person's capacity to fight cancer is or prevent cancer is less in some people and more in some people. So those are all the alternative answers or explanation you would search. And this also ties up with the research methods as well as biostatistical analysis, and we'll see how this really relates to the concept called hypothesis. So when we ask a research question, the process of inquiring into research, we ask questions with beginning with who, when, what, where, how, or is it. And the reason why this is a little bit of things to note is because if you look at those WH questions up there, some of them are not, but those are really trying to focus on exactly what you're looking for, right? If you're looking for a who, then it's persons that you're looking for. If you're looking for when, if the question begins with a when, then you're actually looking for answers related to time. Or if it is what, then you're trying to describe it. If it's where, it's a geographical thing that you're going to try to describe in your research question or trying to answer that question. If it's a how, then you're actually trying to looking for the process of that event happening. And if it's also, is it, like, is it true, is it related, is it different, and you're also trying to look for a specific type of research question. Now, we'll really touch on this later a lot more, and I actually have a slide that describes all of this research question in very much details, um, and tying it up with the type of analysis you do, because those go very much side by side and very much related to each other. So later, but I use that as a summary slide. It's over 150 slides, and after you've gone all through all the concepts of biostatistics fundamentals, that would be an easier slide to take home with you. So let's move on with the basic types of research question. I'm sorry, research methods or the process of inquiry, you could also say. So the first would be your quantitative research, and the second category would be your qualitative research. Now, let us start looking at the difference between these two. And I should have actually put the animation one by one, but I will go through, for example, I will highlight it. I will highlight it so that you understand the difference that we're talking about. So, for example, okay, so let's begin with quantitative research, right? Quantitative research. Quantitative research, as the name goes, it's quantitative, meaning it's quantifiable. You count, you have data that can be counted. So if you have something like that, that means you gotta have numbers. Otherwise, what are you gonna count, right? So the data that you get in quantitative research is usually, not usually actually, or invariably, it's numerical. The data are numerical. So the numerical thing uh, is for the data attribute is very important in quantitative research, as opposed to qualitative research where you have data in words and phrases. Now, let me give you some examples to show how that's true. So, for example, let us say you want to get an idea about the blood pressure of your classmates, right? And you're going to actually measure the blood pressures and see numbers there. There's a systolic blood pressure and there's a diastolic blood pressure, and they give you numbers. So the data that you're collecting, the information that you're collecting are really numbers, okay? So that's a numerical form, and that goes under quantitative research. But if you're asking people, when you have high blood pressure, how do you feel? Or do you at all know how it feels to have high blood pressure? Then the individual respondent is really going to answer in words, saying, maybe I feel good, I feel bad, I don't know how, my shoulder aches, I feel dizzy, like vomiting. Those are all words and phrases, and those actually serve qualitative research purpose. Okay. So data in quantitative research are in numbers like blood pressure, but the experience of blood pressure is really words and phrases, and they are qualitative research data. Then the next one is data are analyzed using statistical calculation in quantitative research. So you're doing analysis for both quantitative and qualitative research, but of course, in quantitative research, it pertains to statistical analysis and calculation. Although it's really mathematics, but the statistics have a different branch, and different ways of doing things, slightly different ways of doing things, a lot of assumptions making, etc., etc. We're not going to ever go into the details of all those calculations, because that's something done by the students of biostatistics and statistics. We are going to try to understand how the statistical calculation is conceptually done, and so that you can at least get an idea about, for example, you're trying to look at the difference between two things, and you're using a formula, of course, there, but you're not really going to know how to put values in that formula and actually do the calculation. You're going to have a concept of why that formula and how that formula works with numbers, and at the end, what you get if you use that formula. Okay, so that's statistical calculation in quantitative research, as opposed to qualitative research, where you have the data analyzed by subjective perspective. So the contrast between these two is, when you're doing statistical calculation, like I said, it's comes from mathematical calculation as well, and that means it's objective. You can't interpret 2 plus 2 as a 5, or anything random. But a subjective perspective would say, the blood pressure experience that I had was terrible, and I couldn't tolerate it. So the researcher takes that into account and thinks, okay, what does that mean? I'm not going to do any statistical calculation. There's really not adding up any numbers or dividing, multiplying anything. But what does a terrible thing mean? And the researcher really interprets that word, uh, that terrible word, uh, based on her or his own experience of the word terrible. But also remember, the person responding with the word terrible maybe using it in a way that someone else is not going to use it that way. So the data itself becomes subjective, the analysis also becomes subjective. And there are, for valid reasons, there are many criticisms of these things, but also there are ways of being. Although the analysis is always going to be, and the data is always going to be subjective in qualitative research, but there are measures you take to limit that and validate that across different research data. Okay, and interpretation, yes. So the next point we see in quantitative research is its sample size calculation. So sample size, well, it's a little early to even speak about sample size, because one can actually start to discuss sample size in end 50% of statistics, I guess, the descriptive statistics actually. Sample size, as you can imagine from the word, um, is is a size, is a number that you're going to get for the uh, respondents or participants that you're engaging in the research. So, for example, you're not going to when you ask a research question and you head out to select participants to participate in the research, you're not going to do it in the entire population. So you want to do a research on Toronto, asking a research question, for example, to so what are the proportion of people who wear snow boots at the beginning of winter, for example, right? And you're not going to go to every person in Toronto and observe or ask whether they use a snow boot right at the beginning of the winter. What you're going to do is you're going to take a portion of that Toronto resident, and that portion of the Toronto resident is your sample, which we'll discuss a little bit later. But how many are you going to take to make a valid answer that is going to be applicable for the entire Toronto population? So are you going to take 30 people and ask them and see, of course, those 30 people, among those 30 people, not everyone is going to be wearing the boot in the first day of winter. But whatever the proportion is going to be wearing it, is it also representative of the entire population, right? And we don't know that. We don't know that until we do a sample size calculation that quantitative researchers would do using specific formula, taking into account different statistical concepts in there and making sure. So that's really one of the core discussion in biostatistics that we will do eventually. But you got to build up some conceptual knowledge around all those concepts before you can actually say, okay, now I'm confident I can understand what sample size calculation is. And that's very rigid and very restrictive in quantitative research. They would, invariably try to do that, and without that sample size calculation, people are very skeptic about what research results you have, whether it's applicable to the entire population. But sample size calculation in qualitative research is not involved. Okay, so if it's not involved in qualitative research, what is involved? How many people do you go to? Well, if you think about that question I was asking, experience about blood pressure, and let's say you're in a clinic asking people about their blood pressures, and they tell their experiences. In the first day you go to the clinic and then you interview 5 people. They're going to say things about blood pressure and you many different kinds of words. I feel giddy, I feel funny, I feel dizzy, I feel bad, whatever. And then they're going to explain it in details, of course. Then you go the next day and you collect data from another different patients on the experiences, and you're going to get different kinds of words. But you will see that the first and the second day, all those 5 plus 5, 10 people are going to have some common answers and responses with similar words and different words. Okay, so there are going to be some commonalities between these two, but also a whole lot of differences. And you take those commonalities, put them aside, and think about, okay, now that we have differences, let's look at on the third day what you get. And on the third day when you interview, then you're going to see that there are going to be probably data coming in that are similar to the differences that you saw. So you're going to get commonalities with the differences that you saw previously with the third day data, and then also differences with the commonalities that you saw in the previous 2 days of data. So you keep on doing that until, to be honest, at some point you're going to get, let's say, within maybe 50 people, I'm just guessing, um, all the answers that have some commonalities with each other. That means if you do more interviews, you're not going to find any more new data that is extremely unique to that person. That is the most likely thing in qualitative research. And that is a point where you're reaching data redundancy. That is a concept of qualitative research. And when you reach data redundancy, that's where your sample size calculation ends. Well, you're not calculating really. You just kept on doing it until your data started repeating itself. um, Basically, and that's an interesting thing with qualitative research, is you bring in data, once you bring in data, you start already analyzing and looking at patterns, right? And then you find words that are common, find words that are uncommon between interviews and among interviews. And you go on the next day trying to look for more answers. You come back, and then you do the analysis again, and it's called an iterative process. So if I ever make a slide on research methods, I will discuss about qualitative research method in details. But people do also these things in quantitative research and qualitative research together. And that's called mixed method research. Let's discuss that a little bit later. When we say hypothesis is not is tested, hypothesis is tested in quantitative research, and hypothesis is generated in qualitative research. What does that mean? First of all, you got to understand what the word hypothesis means. It's not a difficult word to understand. When we probably know what hypothesis mean. It's a presumable answer to a question that we have in mind. So we kind of guess the answer. We have an answer in our mind, and that's the hypothesis. So, for example, if you ask about what's the hypothesis on the winter in Toronto this year, is it going to come early or late, or not come at all? Is it going to be the extreme cold as it happened last year? What's the hypothesis? And you could say, considering the different global temperature patterns, my hypothesis is that there is really not going to be very it's not going to be very much cold next year, so or this year. So the basic point is hypothesis is making a guess based on could be whatever, previous evidence or maybe no evidence. You're just making a wild guess but logical. Wild guess but logical, yeah, that doesn't go together. But wild guess and logical, that's because you don't know it. Now that's a hypothesis in our daily life. In research methods, though, and for biostatistics, you have hypothesis that gets tested by evidence that you collect from your research method, and then start the scientific process of analyzing this evidence through biostatistical methods, like in the previous point, in the second point here that said statistical calculation, right? So I'm going to put the laser point and say statistical calculation. You test your hypothesis and say yes, you're right or wrong. But there are procedures of doing that, and there's specific language to use. So, for example, you have a null hypothesis and an alternative hypothesis, and your null hypothesis really says there is not going to be any change in temperature, and that's what you test in your statistical analysis. We'll discuss about that, so let's not really uh, get ourselves stuck in there. Um, so for qualitative research, hypothesis generated, and you can't guess why, because questions like how do you feel about when you have or do you know how it feels to have high blood pressure, does not have a hypothesis, except that you could say um, yes, people know, and yes, people don't know. If that is the case, then you're not doing really a qualitative research, you're doing a quantitative research. You're going to ask people, do you know? Yes, which equals to yes equals to 1. I don't know equals to 2. And you analyze those numbers. Okay, but really qualitative research says, I'm going to really explore if people know and what kind of experience they have. And then I don't have any presumable answer in my mind. I'm just going to do, unless you really have a lot of background knowledge on this already, but there's no point in doing any research if you already have that. So hypothesis is rather generated. So once you have all those data analyzed from qualitative research that explains the experience of having blood pressure, or people, you get a sense of whether people really know about blood pressure or not. Then you could design a quantitative research to see how many people actually know and how many people don't know about the experiences of having high blood pressure. And that's then you move into quantitative research after qualitative research. It's a common practice nowadays to do them together, and it's called mixed method research. And sometimes you do quality first, then quantitative. Sometimes you do quantitative first, and to explore more, you do qualitative research, and they would be called sequential mixed method research. But that's again a research method discussion that we can have later. Okay, finally, you have the generalization issues, which pertains to uh, quantitative research. Okay, here you go. I'm highlighting it. One of the objective of quantitative research is generalization. That means you are actually trying to remember, we said sample size. We collect a certain number of people to interview or do the research and get information from them in quantitative research. Then we try to extrapolate these findings that we have from analysis of data or information from those certain number of people to the entire population, generalizing it for everyone. Making a notion that it's universal, the result that we got. And that's one of the objective of quantitative research, and we'll really discuss a lot about that, because this is very important in quantitative research, because as you can see, it's an objective, Well, there are exceptions. It's not always an objective, because if you're doing explorative research, even in quantitative research, you're just trying to assess the situation because you've got no idea about what's going on in here, and you will do research that is not generalizable. And it's not also, remember, even though if it's an objective, it's not always so easy to generalize. There are a lot of factors that needs to be there, not a lot of assumptions and conditions that needs to be in place properly to make a generalization of the quantitative findings that you have. Now, with regards to generalization in qualitative research, there's no really such concept, except for there's something called a transferability that's equivalent to your generalization in quantitative research. What transferability is really is saying is that the research that you did in the clinic uh, about the experiences of the blood pressure among people. You gotta, like I said, their answers come from their own growing up, like how they interpret the word terrible. Uh, are they really, people who are weak, old, or something, or do they come from a community that are really stressed out, extreme, in some way? Um, then you have to take all those contexts to explain how these people were responding. Remember, I said you gotta have a way of minimizing the bias of subjective responses or interpretation, and the context really does the trick. If you take the context into consideration, you start to know, okay, so these people are coming from a stressed out community, so the words that they're going to use are probably exaggerated, right? So that's the context you take into account when you do the qualitative research analysis. And then after you conclude to some kind of answers from your research, you can only take this answer and extrapolate to other place or another similar group of population if the context is similar. So if you want to take that answer from a stressed out community about blood pressure experiences and take it to a community that's really there's no day-to-day stress or anything, it's not really going to be applicable there. They probably take these things very lightly. They have their health insurance and everything, they have their medical coverage and everything, they can afford a lot of things that would keep them relaxed, for example. So they're probably not even going to use the word terrible, right? And terrible would be much much more extreme over there. So that's transferability. You take research findings from qualitative research from one specific kind of context, which has many elements, of course, and then only if you can find a similar context, you can get your results from those qualitative research up there to say yes, it can be applied in here as well. But that's not really generalization. That's because it's not going to take the entire population. You got to note that. Okay, so that's a lot of discussion about the basic types of research, but also like I said, it's going to be an overview of the relevant concept for biostatistics. And the reason I discussed here and spent a lot of time here is because these concepts are really discussing a lot of biostatistics. If you don't begin with even phrasing your research let's move question on. Properly, there's a lot of discussion there probably research to reach an answer that's research questions be answered correct and not. There are issues related to that, but let's also see the other point, which is collecting the data or evidence properly, right? And if you're not doing that, obviously you can see that your data are if you have false evidence or impure evidence or data, then of course your answer is not going to be as accurate. So the related issues of phrasing the research question properly first in a research method is literature review. So you do literature review to see if the question that you're trying to answer is even a valid question to ask, for example. So you have background knowledge on all those things that other people have done elsewhere related to your research, and then you can ask, oh, okay, so I can see that people have done already research on the blood pressure in this clinic. Um, so what else is there to look at? Oh, okay, maybe they haven't looked at the difference between blood pressures in different ethnicity. So we could look at that. But of course, there's no point in doing the same research. Well, it's not really a valid point to say there's no point. Sometimes people would repeat research to ensure, and that's one of the concepts called replicability of research, which is important. But a lot of times for many different issues, people don't repeat the same kind of research. But a literature review is going to give you an idea. Has the research been done already? What else needs to be done? If it needs to be done, am I phrasing my research question properly? Um, Based on the literature review, based on the terminologies people have used, based on the different measurements people have used, etc. The second point is really feasibility of exploring. So if you're asking a research question, I'm going to make up a weird one. So, for example, how long can people die? I'm sorry, let me rephrase that. So, how long can people survive under um, minus 20 degrees centigrade underwater? Okay, that's a research really something like that has been done before by the Nazis, but that's not really a research question that is explorable right now. It's not even feasible for doing that. It won't pass your ethics board review. It's insane to even think about this kind of research question right now. But let's take a lighter one. Let's say if you want to explore the psychological state of inmates in Guantanamo Bay. I don't know if that has been closed already, but maybe it has been shut down. But if someone wants to ask a question like that, who is going to give you an access to Guatemala Bay and say, okay, you can start researching on their psychological state of the inmates, blah blah blah. It's different, right? It's a different context where maybe it's not even researchable. You may ask a question. Remember, you may have a research question, but if it's not a researchable question, then there's certainly issues around the feasibility of exploring it, and you got to keep that in mind. So phrasing the research question properly, that's something to keep in mind. Okay, so the next thing in quantitative research, of course, is it's got to be measurable. So whatever you're asking, if you're asking the research question, how do people feel when they have blood pressure, right? Or uh, you know, questions like is wearing boots in the early winter really a comfortable thing to do? Um, you can have measurable things there. People say yes, comfortable, no comfortable, but that's like a black and white thing. Comfort really is not a black and white thing, right? It really has many gray areas and shady areas that you need to explore in details with many words to explain those areas, and that really falls in under the domain of qualitative research. But that doesn't really suggest that you can't do a quantitative research if you have a way to measure it, measure the response that you're getting, then it's of course quantitative. And that related to that concept is what is called an operational definition. So if you want to have this measurable thing defined properly, so by comfort I mean you can wear the boot for 8 hours a day at a stretch. um, if you have that kind of operational definition, then you can do that, but what that ensures is you're only answering the question that relates to the comfort, which is defined by wearing the boot for 8 hours a day at a stretch. Okay, nothing else than that. So it's important to operationalize your definition so that it's measurable and it's clear. Uh, this is all for quantitative research. Remember, we're not discussing qualitative research here. Um, so the collection of data or proper evidence is guaranteed by the research design. So, not all research designs will give you the same kind of evidence or data, because just because of the process of data collection in there and process of selecting participants, and then asking the question. And this is a domain for the research method discussion, really. So I'm not going to discuss this in details, but it has a little implication on the statistical analysis of things, sometimes and interpretation as well. So when we go to that point, and it comes really down the line, like about 10, 12 lectures later, maybe. So not worth really discussing now. Just remember that there are multiple kinds of research design, such as case control, cross-sectional, cohort, experimental. All this research design gives you numbers, right? When you collect data, it gives you numbers, and then you put it in the computer. What do you get? Numbers. And unless you really know how this data were collected based on the research design, you can't really interpret it accurately. So that's something to remember. The next is you have a research design. You're collecting data. What are you collecting with? You're collecting with a tool, right? So you have a measurement tool. The measurement tool development needs to be very appropriate for that research design and the question that you have where you are asking. So it's both related to that, and eventually this measurement tool is going to give you data that you're going to analyze. So it's really important that you keep in mind what kind of analysis you're going to do way ahead of time before even developing your measurement tool. That's because once you collect the data using the measurement tool, whatever you've developed, if it is not really convenient enough to analyze this data that you collected using your tool, then you're going to really be in trouble later. I mean, there are of course ways of doing that, getting around everything, but then it's going to be just difficult. So ideally what you would do is, you phrase your research question, you know what kind of data you're collecting, that's fine, and then you gotta have an idea of what kind of analysis you're doing based on the research design. Then you start developing a research tool, data collection tool or measurement tool, because then you can easily, once you have the data, you can easily analyze them because you already have the plan in hand how to analyze those, right? Okay, but also remember the measurement tool is going to be something very important in collecting the proper data, the proper evidence, right? And it has to be a reliable one. You can't you can't make a measurement tool that is not going to collect information that's not reliable. Okay, so the next point is really reliability and validity of the data collection procedure, and just these two words really is so huge that it by its own self demands a new discipline called psychometrics. It's under biostatistics or statistics, but psychometrics is a discussion about developing measurement tool and nothing else, and discusses all about reliability and validity of data collection tools and procedures. But very briefly, what reliability is, so let's say you have a measurement tool, but that measurement tool is faulty. It's faulty in the sense that, okay, let's give a specific example. You want to measure the height of people. Okay, you have a measuring tape that you're going to measure the height of people with, but the tape is graded in a way that every inch is not an inch. It's probably 1.25 inch or something. So when you're measuring people's height, you're actually measuring height. That's not a problem, but you're measuring it wrong every time. The question is, are you measuring the incorrectness in a specific pattern? Well, of course, because every inch is 1.25 instead of an inch. So when you're measuring it, there is a certain degree of error that you know that's happening for every inch, right? So you're measuring someone who is 4 feet with your tape actually is not 4 feet. You've already measured more than 4 feet because every inch is 1.25. That person is probably shorter than 4 feet, but you're measuring feet height, that's fine. And you're measuring this incorrectness in a specific amount every time with a specific error. So it's reliable. Even then, you call it reliable. It's a weird concept, yes, but it's a reliable tool. It measures the same thing very nicely and consistently. Well, the error, yes, if I know what kind of error I'm making, I can correct it. So it's reliable. But if the measurement tool has, in some places 1.25 inch, in some places 1.35 inch, in other places maybe 1 inch less than that, then it's not going to be a reliable tool anymore. It's not measuring the incorrectness in a consistent manner. And that's not going to be reliable, even if it's measuring height, the purpose it's serving. Okay, and that brings you to the discussion of validity. The validity of the data collection procedure is also, using a measurement tool that's going to be valid, meaning you are measuring height with a measuring tape that is intended to measure height. But if you're measuring height with, and this is going to sound very weird, a blood pressure machine, you'll never do that, I know, but it's weird. Why? Because when people develop questionnaires, now the tools that I've given examples are really instruments, but questionnaires are also called instrument. And if the questionnaire has questions that are asking about, let's say, depression, but your research question was originally to intended to inquire about stress, and the questions in the questionnaire are asking really about depression, then that's not a valid questionnaire, and that's not collecting data properly. So you're not going to be getting the valid data for the research question that you intended to answer on stress. You're going to get information about people's depression. You interpret the result. You can't interpret it for stress anymore. You have to interpret it for depression, which is not your research question. So that's not a valid question. So maybe we'll have some time to discuss in a very later state about reliability and validity, because it really falls also under the research method domain. But when you start analyzing the process of reliability and validity, it falls under the biostatistics domain. So if we get a chance later, we'll do that. Okay, so that's a lot of discussion on how may research questions be answered confidently. We have two more points on that. Well, actually, one, I um, no, two. So analyze the data, of course, and interpret the data properly, right? So you have to correctly analyze your data, the data you get. Otherwise, how can you even answer things correctly or confidently, right? So first of all, you examine the data and see, just looking at the data gives you a sense of, is it working, is it fine? You're collecting, for example, data on people's age, and then you see some of the ages are like 150 years, 180 years, and from that simple examination, just looking at the data, that you didn't really collect correct data, right? So you're doing let's say you're doing research on infants, and you're measuring the age in, let's say, months, and then you see months such as 203 months. Some of your patients have 203 months age and 506 months age. So that's really weird. So you're just looking at the data can give you a sense of whether your data has been collected correctly and your answers are going to be confident enough. So after you do the examination of the data, you know which one is wrong, which one is right. You can go ahead and try to think about an appropriate technique for analysis of the data, but remember, this should be already been thought out well, planned out well, based on the nature of the data that you get and the research question you ask. So that's another discussion that we will do in details later. The nature of the data really tells you what technique you're going to use. There are many techniques in statistical analysis. You'll learn all these concepts, but when to use what is going to be based on the nature of the data and the research question. And remember, you're going to use computer software, statistical software, to do this analysis, right? But the software doesn't know if the data is coming from, your potato sack or your tablet or anything. Is the data coming from an infant or an adult? It doesn't know that. It doesn't even know if it's a month or a year. It just knows the number, right? And it's going to speed out all these results after analysis. Your objective is to interpret those results, and if you don't know what analysis to do based on the nature of the data or the research question, it's going to be a flawed conclusion. So look at the outputs from the data analysis software, and you start interpreting them appropriately based on your research question, of course. But you got to interpret all those estimates properly to answer the research question. We'll see this is really pertaining to software usage. So when you use software, you have lots of tables and outputs, and we're going to particularly use here SPSS, and then in some places Stata or maybe even SAS. But I'm going to just show you a comparison of all these things and how data are interpreted from the outputs. Okay, so let's move on to the basic types of research questions. And this is something you'll not really find in the text, but over the years teaching statistics and research methods, I've figured out that because statistical analysis procedure, the decision of that really depends also on the nature of the research question, and it's really correlated. It's a certain kind of research question really uses a certain kind of data analysis procedure. So I've divided them into three categories. There could be more, of course, but I find three broad categories of research questions that people can ask and really stick to specific type of data analysis procedure. So, for example, one of them is a descriptive research question. So these are questions that really ask to describe the status of something in numbers, because it's quantitative research. The other one is relational or difference. So research questions that ask about relationship or difference between something. So, for example, the very first question that we asked in the initial slide is the locally produced drug different from the internationally produced drugs, right? So that's a difference question, but there are also relational questions. And let's look at the examples of the descriptive. So, for example, we can ask, how much does a paracetamol tablet weigh for company A, company B, and company C? And that is also only telling you a description of the weight of these tablets in grams, maybe, or milligrams, right? So that's all it's doing. Company A, company B, company C, you get different samples from those companies, and you just weigh them and then get an average for each of those companies and then say, here's my result. That's it, descriptive. But a relational question is something going to be, is there a relationship between the weight of the paracetamol tablet and the onset of its action, right? So that's a relationship. You have two things to relate with, and one of them is weight of the paracetamol tablet, and the other is onset. I don't know. Maybe you may have some relationship. You know, if it's a weight more, then maybe it has more ingredients. Maybe I'm just guessing it as an hypothesis. But does it determine also how fast it's going to act in your body, right? But you gotta. There are two things to relate here usually, and that's what you do. But there could be multiple things to relate also in other research questions, and this specifically will determine what kind of data analysis you're going to do. Also based on your nature of what kind of data you're getting here, you'll see later that the weight is a certain kind of data, numerical data called continuous. But the onset of action, if it's a time, it's also a numerical continuous data, and then they have specific kind of analysis called a t-test or something, or a correlation. But if you're looking at a difference, then you're looking at, questions like, what is the difference between mean weight of paracetamol tablets from different companies? So the first descriptive question that you've seen, how much does a paracetamol tablet weigh for company A, company B, company C? Now you may want to ask even, so here I have all these different weights, but do they really differ significantly? Statistically, are they significantly different? That's the question you're asking here. And again, if it's three companies and you get a mean weight, you'll do a certain kind of analysis called, it's a continuous variable. It's a continuous data that you're getting in numbers, and you're comparing three different company means of the paracetamol weight, and you're going to do a test called ANOVA. So like I said, data, nature of data, and then also the research question that you're asking determines your way of analysis. Called a causal. I call it a causal kind of research question. So any research question that asks about issues causing certain effects. So notice the question here. Does paracetamol help to relieve fever and reinstate body temperature? Right? That's a cause and an effect we're looking at. We're looking at the dose of paracetamol as a cause, and whether it helps to relieve fever is an effect. But you also note that it's not properly operationalized, because if it was operationalized, then you would really put in numbers there, like relieve fever and reinstate normal body temperature to 37.5. It could even cause hypothermia, I don't know, but then you may want to specify that. Are you looking for a hypothermic condition because of the dose of the paracetamol, right? But the point here is this kind of causal research question really asks, it really points out that it contains a cause and there is an effect, and there is specific analysis for this also, which are closely related to the previous one, but also there are eventually differences where you want to look at the strength of this cause, and really if there's an association or not. And you could think about other examples also, and maybe other categories maybe might just come across when you're reading literature or something. So let's now move on to what is the processes of statistics in research. Very simply, this is really common sense. I'm not going to really discuss this in detail, but you should already get a sense of what's happening here. For example, statistics analyzes quantified and empirical data to answer your research questions, right? So you have a research question, you're collecting data and their numbers, so statistics is going to analyze them for you, and they're going to be interpreted in a numerical way, numerical results, and then you interpret it in a wordy results. I'm sorry. You'll have, there's a word here that's called empirical. Now that's where I want to highlight a little bit. The word empirical really means it's evidence based. It's something that you get firsthand observation. Okay, um, so that's something they use in the world of quantitative research, actually research method as a whole. Okay, so most of the times, an analysis do not require recognizing the disciplines from the data. When I discussed this earlier, it only recognizes the numbers when you're doing the analysis in the computer. So you don't really know you're getting it from, like you said, a tablets and mean weight of potato sack. It doesn't make any difference to the computer. In statistical analysis, the two means are merely numbers. You can put numbers in your formula and spit it out, equal to something, and that's still going to be numbers. You're not saying whether it's coming from. So that's something that statistics does in research. Takes numbers, analyzes them. It is your responsibility as a researcher, um, or a reader of research, to understand where these data are coming from, because the interpretation will largely depend on this. Moving on, we see that statistical analysis really help research question, answer research question by analyzing numbers obtained as data, quantitative numerical data, right? And different disciplines that really have slightly customized use of statistics, and likewise they just made different branches of statistics. And for example, you have pharmaceutical statistics, biostatistics, agricultural statistics, and business statistics, and then you can have more numbers. Just Google for it and you'll see so many different disciplines of statistics and branches. Point is really, even with pharmaceutical statistics, for example, the branch, it really takes into discipline in pharmacy, right? And the pharmaceutical statistics can play a role in answering questions like, for developing new drugs, quality assessment, or consumer and consumer market and behavior of the customers, like practices, like informing the policy whether good drugs, bad drugs, take it out from the market or something, could be more. But the question then is, why then is biostatistics so important and different? Well, what I've seen is that biostatistics kind of harbors all the element of statistics and applies to any discipline that has biological entities. Okay, so even in pharmaceutical statistics, if it kind of involves people's, let's say, bioequivalence, right? So bioequivalence is really something that goes on in human body. You could you couldn't really differentiate between pharmaceutical statistics and biostatistics here. Um, People may say that, but I don't really agree that it's a whole lot of difference. It uses the same concept really. So what you're going to do really is have some common and basic skills from statistics, and that can be applied to almost any branch of statistics, right? So the trick really is what we discussed before, is to focus on the fundamental element of statistics. And if you remember, it's really numbers, okay? The numbers and the questions, okay? And based on the numbers and questions, you're going to analyze the data. But based on the questions, you're going to have specific research design and your instrument tools and collect data and then analyze them, okay? And using the software. So if you can do that, you're achieving it. Okay, you're achieving it. Uh, of course, you have to interpret it according to your back to your research question. Okay, so if you're trying to answer a question, the concept of population and sample is very important, something that we started to discuss a little bit earlier, and we're really near the end of the slides discussing what they are. It's very simple. It's very simple. Population, as you can imagine, is the whole thing. It's everything that you should be able to consider. Some people call it universe. Some people have the term population under universe, and then some people call it target population for program intervention, for example. But the basic concept is it's everyone you have ever considered. So if you have a research question asking, and remember, you usually ask research question about the population. So remember, we asked the question, uh, do the residents of Toronto use boots? Or what proportion of the residents in Toronto uses boots on the first day of winter? And that's asking about the entire population of Toronto. But what you're going to take is really a sample, and the sample is really a part of the whole. Okay, so maybe we go to Scarborough Town Center and then start analyzing. I'm sorry, start collecting data, or just sitting down and observing the first day of winter and see how many people are using snow boots. So you're taking a part of the whole Toronto residents, because a lot of Toronto residents are just coming in there, but of course not from everyone is there. And I'll give you another example. Like, Bangladesh has a population of 160 million, which is, density wise, it's like 305 times more than Canada as a whole. You think you're really going to collect, if you have a question about Bangladesh, you're really going to collect data from every individual people? No, you're not going to do that. You're going to take a population, a sample, for example, maybe 100 people from whole Bangladesh, and do your research. And that 100 is part of the whole. I'm going to give you even a better example to remember what really sample is. And it's something because we use in our daily life very often. So let's say you go to a physician for a certain kind of fever, God forbid, but let's say you do that, and then the physician really asks you, okay, you know what, I can't understand beyond your symptoms and sign. I really need to do a diagnostic test on your blood. So go and do a blood test. And when you go to the diagnostic center, what are they going to ask for? Sample, the blood sample. Okay. Imagine this whole thing, this whole circular thing is your body's blood, all those cells in your blood. This is all the blood you have, 4.5 to 6 liters on an average in human body, maybe. That's all you have. No one is going to take all of your blood and say, you know what, the doctor gave a blood sample test, I need to see the situation in the entire blood. No, that would be out of question, right? Um, Medical practice would really stop in there. But what they say is, can I, taking your consent, saying that I will need to draw a sample of blood from your body, maybe taking 3 milliliters or something, 1 milliliter. He's taking the diagnostic guy is taking a sample of the entire blood. Okay, so maybe sample from here or a sample from here, sample from here. Although in research you take just one sample and do the analysis on the sample and conclude how your blood picture looks like for your whole body. That is actually research and statistics. That's all it's doing. In the process of analysis, there are many concepts and things that we're going to discuss over time, but this is kind of summarizing, the population and the sample and the relationship. And but we have a better picture in the next slide, how they're related in research and statistics is going to be discussed, and you got to keep in mind about that thing. So you may ask what this thing is, this weird sign. Well, those of you who don't know, it's a Greek letter mu. It stands for the population mean or average. For sample average or mean, we actually use what is called an X bar. So we write X and put a bar over there. We're going to discuss about this a lot later. That kind of concludes the discussion, and you may ask questions in my YouTube page or my blog page, Shuvra Stat, so that we'll just, I can also respond to them either mostly by typing out. And the part one of descriptive statistics. I really thank you for your attention and look forward to you looking or watching my next video. Thank you very much.